Welcome back. So up until this point, we've dealt with inequality notation. We've seen how to graph an inequality on an interval graph, and we've dealt with set notation. So a fourth way we can express inequalities is called interval notation. So we're going to look at interval notation. Okay. Here we use brackets and parentheses. Now, open parentheses means that we do not include the given number in our solution. We exclude it. On a number line, you might recall, to not include a point or to exclude a point, we put an open circle and then just shade around it. This occurs when we have the inequalities greater than or less than. We don't include the particular value or a point in our solution set. Now, a closed bracket is when we do include the given value in our solution. We saw this on a number line where we placed a closed circle. And this happens when we see the notation less than or equal to or greater than or equal to. So closed brackets, we include the value in our solution set. So let's go ahead and take a look at a few examples using this interval notation. So let's say we want to write an interval notation, the inequality x is greater than 20. Okay, so we don't have an equal sign here, it's just greater than, so we're going to use a parentheses at 20 because we're not including 20. But we do want to include all the numbers greater than 20. So going to the right, what number do we choose? Well, here's where we're going to encounter the concept called infinity. Infinity is, like I said, is more of a concept than a number. And there's no end to it, so we actually can't include infinity, because the best way I can describe this is that infinity can't be measured or plugged into a variable. It's not a number, it can't be solved for, so to speak. We can think about infinity as moving to larger and larger numbers. And notice infinity can actually go in both directions. We can have negative infinity or positive infinity. So we can think about this, all the numbers greater than 20 in the positive direction will include all the numbers going off into infinity. Okay, so since infinity is not a number, we can't include it in our solution interval, so we use these open parentheses at infinity. And just like we're not including 20 in our solution interval, we use open parentheses for that one. All right, let's look at a few more examples of this. Let's say we want to write the following inequality in interval notation. We have x is less than or equal to minus 12. Here, we're looking for all the values that are less than or equal to minus 12. So that means we're going to start with negative infinity, because we want all the numbers that are less in value than negative 12 going in the negative direction. And just like positive infinity, we can't include infinity in the solution set because it's actually not a number. So we just put parentheses around it. And over here, we put our 12. And since we have a less than or equal to sign, we're going to include minus 12, in our solution set. So we're going to put a bracket over here. Now don't get excited that we have a parentheses and a closed bracket in the same interval notation. This is actually quite common. We're just simply saying that we're not including minus infinity, but we are including minus 12. Okay, so this is the interval notation for the inequality x is less than or equal to minus 12. Let's get familiar with this by looking at a few more. Let's say we want to write an interval notation, the inequality x is less than 8. Okay, so we're looking for all the values that are less than 8. So we know 8's going to be on the right, and we're not including it in our interval because it's just less than. It's not less than or equal to, so we're going to place a parentheses around this. Now we want the numbers that are less than 8, so we're going to move from left to right, and we're going off in the negative direction. So we're going to include, or we're going to exclude negative infinity, but negative infinity is in our solution interval. So this is the interval notation for x is less than 8. We're not including 8, but we are including all the values that are less than 8 going in the negative direction. So we go off in negative infinity. Okay. Once we get a good handle on this, these are actually fairly simple. Let's write an interval notation. X is greater than or equal to 40. X is greater than or equal to 40. Well, we know that we're going to include 40 in our solution set. So let's put a 40, and we're looking for all the numbers that are greater than 40, so 40 is going to be the lowest number if you want to think of it like that, so it's going to be on the left. We're going to include 40 with a closed bracket, and going from left to right, since we're going from x to all the values greater than x, we're going to include all the values off towards infinity. And we put open parentheses at infinity because we can include infinity. It's not a number, but we're including all the values starting with 40 going off into infinity. All right, let's do a few more. Let's look at the inequality x is greater than 0. Or in other words, all the positive values, all positive real numbers. Okay, so we want to start with 0, but we're not including it. So we're going to put an open parentheses at 0, and we want all the numbers greater than 0. So the interval is going to be 0 to infinity. Infinity always has a parentheses, and this is our interval notation for x is greater than 0. It's the set of all positive numbers. Let's look at the next one. Let's say we have x is less than or equal to minus 2. X is less than or equal to minus 2. Well, we're looking for all the values less than this particular value, so it's going to go off into negative infinity on the left, and on the right we're going to have minus 2. Now we're including minus 2 in our interval because of the equal sign. It's less than or equal to minus 2, so we can actually have minus 2 as a valid value for our variable x. So we're going to put a bracket around it. So this is read as x, all the values less than or equal to minus 2 are included in our interval set. We're including minus 2 and all the values less than that, all the way into negative infinity. Okay, so this interval notation is extremely important, especially when we move on to taking a look at another version of an interval graph. We're not going to be using, it's actually in the next section we're going to be doing this. We're not going to be using the closed dot or the open circle for less than or less than and equal to. We're actually going to move on to actually using these parentheses and these brackets. So we're going to see that whenever we're including a number in our solution set, we're going to put a closed bracket or an open bracket on the number line, and with a circle, we're excluding the value from our interval solution. We're going to put a parentheses either to the left or to the right. So we're going to transition from this notation to this notation in the next section. So I'll see you soon.